All right, welcome to our second video for Chapter 6. In this video, we're going to talk about annuities and the effects of different time periods on our calculations. All right. Now, annuities are equal flows of cash over equal periods of time. So you could have a scenario where you're saving money maybe every year. So maybe you'll save $100 every year for the next 10 years, or you may say, I'm going to put away, say, $20 every week, or you are going to get paid $62.83 every 9 days. Any of those things would be weird, wouldn't it? Anyway, any of those would be annuities, and we can use the tables and use our present value, future value calculations with annuities as well. So let's get to it. Now, there are two types of annuities. There are ordinary annuities and annuities due. And the difference depends on when the flows of cash start. So for an ordinary annuity, the cash flow starts at the end of the first period, and then each of the following payments is also at the end of the next period. So the cash flows are at the end of each period. Now for an annuity due, the cash flow is at the beginning of each period. Okay, so let's look at a couple of examples and hopefully you'll see the differences. Again, we're following along in your chapter course notes, your student notes. So we decide to put $100 in the bank at the end of every year for the next 3 years. How much money will we have at the end of 3 years if the interest rate is 6%? So of course we're going to put together a timeline. And here's our timeline. We have present value on the left and the future values on the right. And again, ignoring that first line over present value because that's the 0 line, we have 1, 2, 3 lines till we get to the future value because we have 3 years. Now, we're going to have to put that $100 on our timeline. And the question is, where does it go? Right? So let's read it again. We decide to put $100 in the bank at the end of every year for the next 3 years. So where are you going to put that $100? Are you going to put it on the first line over the present value, or the next line, or the third line, or the fourth line, or are you going to put it on more than one line? So I want you to take a guess, try it out, put that $100 somewhere on your timeline. Hopefully you're going to match mine. Take a guess. All right. It should be on those lines that you see right there, on the second, third, and fourth, but the end of year 1, the end of year 2, and the end of year 3, because it's every year for 3 years. Okay. Then we're going to put the X, the how much. How much money do we have at the end of 3 years? And so where does the X go? Does it go over the PV line, or does it go over the next line, or the third line, or the fourth line? So put it where you think it goes. How much money will we have at the end of 3 years? Now, I know it might not look great, but put it somewhere. Maybe not where you want to put it, but where it belongs. All right, hopefully you have it right there over the future value, because it's asking us, how much are we going to have in the future, not how much will we have today. I know it looks funny, but it can look like this, okay? So now once we have our timeline, we can put together our formula. And now these formulas are different, but they're very similar to the ones that we learned in our first video. And so again, what's on the left-hand side is what we're looking for, and what's on the right-hand, and then the right-hand side will be our formula. So over there on the left-hand side, we have the future value. That's what we're looking for. Now, I've subscripted this OA for ordinary annuity. You don't have to, or you could subscript it differently, but you want to make sure it's different from your single sum formula. And you'll see that the formula is slightly different. It's the future value of an ordinary annuity is equal to the rent times the future value factor of an ordinary annuity for the right interest rate and the right number of periods, right? You see a theme here, I hope. Okay. So now again, what's on the left-hand side is the table that you're looking for on the right-hand side. Okay? So now we're going to fill in what we know. And you'll see there that for the rent, I just put $100 because the amount we are paying each time is the same. So you only put it in there one time. You don't add them together. You don't multiply by 3. you just put the one individual payment amount into your formula. So the future value of an ordinary annuity is equal to $100 times the table factor, the appropriate table factor, for 6% interest and 3 periods. So we're going to go to the future value of an ordinary annuity table, right? So again, that's table 3, but you can see the title there. And we'll go over to 6% and down to 3 periods, right? And where they intersect at 3.1836 is the number that we're going to use for our formula. So we can now put the 3.1836 into our formula, multiply it by $100, so you get $318.36. So this makes sense, right? If I put $100 in the bank 3 times, and there's interest, then I'll have the $300 plus I'll have the interest of $18.36. There's nothing magical here, right? Okay, let's try a present value. And this is a happy example, right? We win the lottery and they offer us $80,000 at the end of each year for the next 4 years. What would be the equivalent lump sum amount that they would offer me today if the interest rate was 4%? So I want to know what is equal to this annuity, right? So this $80,000. Okay. So again, my timeline, present value on the left, future value on the right. We have the 4 years there designated, right? Now, where are you going to put that $80,000 on the chart? I want you to put the $80,000. Remember, it's at the end of each year for the next 4 years. So take a guess. And hopefully you have it where I have it, right? So it's not going to be on the PV line because that would be at the beginning of the year. So it's going to start at the end of the first year, end of the second, third, and the end of the 4th years. That's where my $80,000 is. Okay? So then we have to figure out where the X goes. And it said, what would be the equivalent sum, that's the X, that they would offer me today? So put the X somewhere on the table, on the timeline, where you think it belongs. And hopefully you have it right there on the present value. So this is what the present value of an ordinary annuity looks like, right? So you can kind of think about this, picture it in your head. This looks different from the future value of an ordinary annuity, and it looks very different from the present value of a single sum. So, right, you want to compare these. All right. So now we're going to put together our formula. I think you can probably guess the formula. The present value of an ordinary annuity is equal to the rent, the single individual payment, times the right table factor with the right interest rate and the right number of periods. So if we put in what we know, right, we know the rent is equal to $80,000. It's one individual payment. You don't put the multiple payments, just the one amount, because the table is going to do the work for us. We know the interest rate is 4% and it's 4 periods. So our table for present value of an ordinary annuity, right? So we're going to go over to 4%. And then we'll go down to 4 periods. So there we have the intersection of 3.6299. So if we put that amount into our formula and we calculate it, then we find that the present value of an ordinary annuity for this lottery winnings is $290,392. And so if the lottery offered me $290,000 today or $80,000 a year for the next 4 years, I probably wouldn't care, right? But the lottery's not going to offer me $290,000. When those people take the lump sum, they are taking an amount that's much less than that because the lottery does the math and then they offer you less. And there's nothing illegal about it. You can do this math and you can decide whether it's worth it or not to you, right? All right. Let's try this last annuity in our notes. So instead, we win the lottery and they offer me $80,000 at the beginning of each year, starting today for the next 4 years. So I want you guys, you can pause the video if you want, right? I want you to fill out the table, and then I want you to see if you can write down the formula, see what you think, okay? So pause the video because I'm going to give the answer now. Okay? So in this case, we have the X, the present value is the X, and then we have our cash flows of $80,000 starting today, right? You can see that it looks different than the ordinary annuity one. And there's our formula and our answer, right? So the rent is still $80,000. And you'll see here that I've subscripted the present value as annuity due, not OA, but I used AD, so I remind myself to use a different table, right? This is the annuity due table. And hopefully you looked it up on the annuity due table, and you'll find that I'm not going to show you the table, right? Again, you guys can look at the tables. It's table 5. And then that table factor is 3.77509. And so the present value of the annuity due is $302,007. So you can see that between paying me at the beginning of each year or the end of each year, it's worth a different amount, right? It's $12,000 difference. And that's because that first $80,000 is in the bank for a whole extra year. So that's why it's so much more. And again, even if this was the cash flows, the lottery would not offer me $302,000. They would probably offer me a lot less. And I could just decide which do I want to take, right? Do I want to wait or do I want the lump sum today? All right. Now, each of these problems has used a year for each one, an annual interest rate. But you can do these with less than a year as well. So when you have different periods of time, you can still use the table factor, the tables and that we have. So, but what we have to do is we have to make sure that the interest rate and the period of time match one another. Okay, so we're going to go through a couple of examples. I think that's the easiest way to do it, and then I'll let you guys try with the notes. So this is just something I'm making up. Okay, so what if we make, and we'll just think about this logically. What if we make payments twice a year? So we're going to make our payments semi-annually for 1 year, and the interest rate is 10%. Now, interest rates are always given in annual interest rates, just so you know. They're always annual, unless it says 10% per day. That would be terrible. Don't do anything with that, unless they're paying you 10% per day. Anyway. All right. So let's think about this. If I'm earning 10% for the whole year, how much interest am I earning for the half a year? Right? So hopefully this is me thinking about it. 10% for the whole year, how much am I earning for half a year? I'm earning 5%. Right? So for the semi-annual period, each semi-annual period, I'm earning 5%. Okay. Now, then we ask ourselves, so that's now 5% per period, per semi-annual period. And then it's, so how many semi-annual periods are in 1 year? Well, there's 2 semi-annual periods in 1 year. So on the tables, we would use 5% per 2 semi-annual periods, right? So we would use 5% and 2. All right, let's try another one. What if we make payments quarterly for 5 years and the interest rate is 8%? Okay, so it's 8% for the whole year, but I want to break it into quarters. There's 4 quarters. So if there's 4 quarters in a year, then that means for every quarter I'm earning 2% interest, right? 8% divided by 4. So then we have 2% per quarter. And in 5 years, there's going to be 20 quarters. Okay? So 5 years, there'll be 20 quarters. All right, so I want you guys to try the problems in your notes, but you have to stop the video, okay, because I'm going to put the answers up pretty quickly. But stop the video right now, and then you can do the ones that are in your notes, and then you can check them. Okay, so here they are for the first 2, right? 12% compounded or received semi-annually, that's going to be 12% divided by 2, or 6% per period. And if it's 4 years, then it would be 4 times 2 for 8 periods. Second one is 16% receiving payments quarterly, so that's going to be 4% per quarter. And if we do that for 3 years, that'll be 12 periods. And our last one, if it's 12% payments monthly, then it's going to be 1% per month. And if it's 5 years, then we'll use 60 periods. Okay. So go back if I have any trouble, and I hope that I'll see you in the 3rd video where we're going to talk about deferred annuities.